Hello, geometry. Welcome back. This review video, it's the third one for Unit 8 Quest 1 review packet. It's only going to focus on problems 22 through 27, or page 3 in your review packet. Okay? If you need to get a hold of me by email, my email is right on the left-hand corner in green, gwrees@fcpsschools.net. Let's start off with problem 22. So finding the value of A, we got to study the picture a little bit. We see that we have a circle. This is called circle Y because the center of the circle has point Y in it. So it's circle Y. Notice where the A is at. We got an A with a degree symbol. So there's an angle that has A in it. And there's also another angle that has 2A plus 24 all together as a degree expression. So actually we have two angles. Now, what kind of angles are they? So remember, there's different kind of angles that are formed within a circle. And here, anytime that we have an angle that has a vertex as the center of its angle, then we call them central angles. So by definition, you have two central angles here that have the variable A involved. What else can you tell me about this picture? If you look a little bit closer, we can tell that beginning from this point X, going through the center Y, all the way to the other side of the circle, that should be the diameter of the circle, okay? What happens whenever there's a diameter of a circle? You notice that we create semicircles. So once we see that there's a diameter that is happening, you can see it clearly, then you can kind of see that there are two semicircles. I'm going to create both of them here. So there's one in yellow, one in green. And you happen to know some information about semicircle. You know that a semicircle, it measures 180 degrees. I'm going to let me erase this little green here. So a semicircle measures 180 degrees. So what we know then about these two angles over here is that this central angle, XYZ, which happens to measure 2A plus 24, then I should also know that its arc is also 2A plus 24, okay? The same thing with this central angle here, which just has A in it, right? This central angle, its measure is just A. Let me write this over here. So I know that this arc over here is 2A plus 24. Okay. And since we know that a semicircle adds up to 180, I want you to begin to think about, okay, well, whenever we're solving for a variable, we must create an equation. We must get creative here and try to create an equation. So why don't we try to do that? So possible equation that we can think about here to solve for A is that we're going to take 2A plus 24. So that's that green arc. We're going to add it to the red arc, which is also value of A. When you add those together, they form a semicircle. So adding both of those arcs together, a semicircle adds up to 180 degrees. So here's your equation that we're looking at. Let me see if I can change the color of this so we can stand out just a little bit more. All right, let me get bold. So now solving this equation, 2A plus 24 plus A equals 180. Let's see if we can combine like terms. So on this side of the equation, we get, let me move this a little bit. We get 2A plus A, so that gives me 3A plus 24 equals 180. Okay. And from here, you want to go ahead and subtract this 24 on both sides, right? So when we subtract 24 from both sides, we're going to end up with 3a equals to 156. Okay. Last thing you gotta do is divide both sides by 3. So using your calculator, 156 divided by 3 will result in a value of a equals 52. Right. So the final answer would be a equals 52 degrees. All right. Moving on to 23. Taking the same idea here for 23, let me delete this. So here in 23, we got lots of central angles. You got one central angle, here's another one, and here's another one. So the biggest central angle here measures 20a minus 30 degrees. The next biggest central angle has a measurement of 10a plus 2 degrees. And then the smallest central angle has a measurement of 2a plus 4 degrees. So knowing what we just did in this problem 22, we can then begin to figure out, okay, what's the measure of all these arcs? So remember, when you have central angles, the arc is equal to the measurement of its central angle. We know that a full circle, okay, so we know that a full circle measures 360 degrees. So in this case, there's no diameter. We see that we have 3 different radii, but there's no diameter. There's nowhere for me to like split the circle in half. So I can't create an equation that I could set up and say, okay, it's going to equal to 180. But here we know everything about all these 3 different arcs, and we know that all the arcs in a circle, when they're added up together, they create that one whole circle, and it all equals to 360 degrees. Okay, so let's start thinking about, okay, where are these arcs? Just to make sure we can see them, I'm going to go ahead and highlight them in different colors. So this arc right here measures 10a plus 2. This arc right here in blue measures 2a plus 4. And then I'm going to use this arc over here, the big arc in yellow. It measures 20a minus 30, right? So when we write an equation, one possible equation, let's add up all those arcs. So we got 20a minus 30 plus 10a plus 2 plus 2a plus 4. And since they all add up together to form that full circle, they're all going to add up to 360 degrees. Okay. Let me move this to the middle. Combining like terms, once you take this 20a and this 10a and this 2a, we should end up with 32a. Okay. Then we're going to take this negative 30 and then plus this 2 and then plus this 4. We're going to end up with negative 24. And that all equals 360. Continuing to use your algebra skills here, let's go ahead and move this negative 24 by adding 24 to both sides. Okay. So we're going to end up with 32a equals to 384. And then now divide both sides by 32, right? So let's use our calculator. 384 divided by 32 gives us a value of 12. So here we go. Find out that a is equal to 12. Excellent. Okay. 24 and 25. Notice that we are looking for something different. In 24 and 25, we are finding the length, so the distance, of some arcs here. All right, so 24, let's look at 24. It says find the length of arc AB. So again, AB has two letters, it's an arc. It must mean that I have a minor arc to look for. So let me go ahead and highlight in blue what exactly we're looking for. So we're looking for this arc right here. We want to know how long this arc AB is. So remember, if you think about it this way, remember the outside of the circle or whatever's on the circle, kind of like perimeter. So perimeter for circles are associated with the word circumference. So here I need to use the circumference formula. So remember, the circumference is 2 pi r, right? Okay. Now, 2 pi r, that's the circumference of a full circle. Now, I just need to find this little piece of this arc right here, okay? I happen to know that the arc measure is 90 degrees. So that means that the central angle measure, that means that this angle right here, let me make sure I use the right symbol. That measure of that angle happens to also be 90 degrees, which means it's a right angle, right? This is 90 degrees in here. So remember, this is when we started to do lesson 3, when we were beginning to find the length of an arc length, and then we were also beginning to explore finding the area of a sector of a circle. So here we need to add something in front of the circumference formula, which remember is a fraction. And that fraction has to deal with what part of the circle that's going to be in your numerator that we're interested in out of the whole circle. And remember, because the whole circle measures 360 degrees, 360 degrees is always in your denominator. So the numerator here, I need to know what is the angle associated with the length of the arc that we're looking for. Well, it happens to be 90 degrees. So we're looking for this quantity of 90 degrees over 360 times then the circumference formula, 2 pi r. And notice that here for this problem, that r is equal to 10, okay? So using our calculator, we're going to get 90 over 360 times 2 pi r, which is 10. So let's go ahead and type that in. Now remember, I like to use alpha y equals 1 to use our fraction boxes here. So I'm going to put 90 in the numerator, arrow down. Let's put 360 in the denominator and arrow out. And then let's go ahead and put 2. Remember, you need your second button for blue pi to get the pi out. And then we're going to type in the value of 10, because that is the value of the radius. Hit enter. And then we end up finding out that the length is 15.70796,327. And here I'm going to go ahead and invite you to practice, to just go ahead and round off to the nearest 10th. So rounding off to the nearest 10th, since 10 only has 1 0 in it, I need one number after the decimal. However, we always have to look at the neighbor, what's next to it. If it's 5 or more, then we increment that number by 1. Here it's 0, so we're just going to keep it at 15.7, all right? So the length of, so now I'm going to write arc AB is equal to 15.7. And then what are the units that we have for the radius? So here the radius is in centimeters. So I'm going to use the units of centimeters to determine or to describe the length of the arc AB. Okay, so here is our final answer. Okay, 24 and 25 are very similar. Here for 25, it says find the length of the major arc. So here at major arc means that we must be looking at an arc that is bigger than a semicircle, right? So far, what I know about this circle is that the radius is equal to 20 meters, right? And I know that this arc right here, it's very small. It's 45 degrees. 45 degrees means that this is a minor arc. So this is minor arc, which means then that's not the arc I'm interested in. I don't want to use that one. Well, if this is 45 degrees, then I need to know what is going to be the measure of the arc, or should I say, yeah, what's going to be the measure of this arc in blue? And I'm doing a very bad job trying to copy it here. Okay. So if this is 45, what's the rest of this circle arc? What's the rest of this circle's arc going to measure? So take 360 minus 45. So that's a full circle, right? We know that that arc, that little minor arc, is 45 degrees. So let's subtract it and you end up with 315. So going back, I know that the arc, the major arc, this one, is 315 degrees, right? Which means then that the angle inside, the central angle of this circle, is also 315 degrees. Okay? So pretty much we're going to use the same formula that we used to find the length of arc AB to find the length of the major arc. We're going to take the portion of the circle that we're looking for to find the length. Well, that arc measures 315. So we take 315 degrees. And that was in our numerator, and our denominator is the whole circle. So we're taking part of the circle. Do you see that? It's a ratio. Part of the circle that we're interested in is 315 degrees over 360. Then we multiply it by our circumference formula. So 2 pi, and then the radius was 20. So we're going to multiply it by 20. Sorry, my 20 came out really big. All right, now let's go ahead and multiply all this in our calculator. So again, fraction boxes, alpha y equals 1. We're going to put 315. Let's arrow down 360. Then we're going to multiply by 2 into your pi. And then we're going to put 20 for the radius. I'm going to hit enter. And then we have a value of 109.9557429. And again, I invite you to round this off to the nearest tenth. So rounding it off to the nearest tenth, I know that 10 has 1 0, so I want one number after the decimal. So here we have 0.9. We got to look at its neighbor. If it's 5 or larger, that means that we have to increment this 9 by 1 unit. Well, what happens when we add 1 to 9? It turns to 10, right? So this 9 is going to be a 0, which means that I'm also going to have to add a 1 to the 9 that's before the decimal. So this is kind of an interesting rounding problem. Your final answer here, rounding off to the nearest tenth, is going to be 110.0, and then the units that were in the radius were meters. So therefore, the length of the major arc in problem 25 is 110.0 meters, rounded off to the nearest tenth. Okay, how are you doing? Not too difficult, huh? All right. So we're going to do the same thing. We need to find the part of the circle. How much of the circle is it that we're using up? So how many degrees? Because we're going to have to use a fraction. But here, notice how 26 and 27, now we're looking for the area of the shaded sector. So instead of using the circumference formula here, we're going to use the area formula. So I just want to remind you that the area is equal to pi, and then times the radius squared. Okay, so that's the area part. Then we just need to figure out the fraction part. What's the part of the circle that we're interested in? The area of the shaded sector. So looking at 26, here we can tell that the arc measure is 60 degrees from arc AB. We notice that the area of the shaded sector is intercepted by arc ACB. All right, so this angle here, since it's a central angle, it also has a measure of 60 degrees. So therefore, we can start off, let me erase this. We can start off with our fraction. The part of the circle that we're interested in is only 60 degrees of it. So that's going to be in our numerator. The whole fraction, the whole circle measures 360. So here's our ratio. We only want to find the 60-degree part of the shaded area of the whole circle, which is 360 degrees. So that's why we have a fraction of 60 degrees over 360. Now we're going to multiply it using the area formula. So we're going to have pi. And then we're going to take the radius. The radius is 10. And then if you take 10 and square it, you know it's 100. All right. So here I'm going to put this in my calculator. 60 divided by 360 times 100 pi. So alpha y equals 1. Let's do 60 divided by 360. Arrow out. Then we'll go ahead and do pi. And then we already squared the 10, so it was 100. Enter. And so we have something that is 52.35987756. So let's round that off to the nearest tenth. So what do you guess your final answer is going to be? So I need nearest tenth. That's one decimal. Look at its neighbor. Did you say 52.4? If you did, you are awesome. 52.4. And then here, look at the units of the radius. It's in inches. So remember, since we squared the radius, right, we also have to square the units of the radius. So your final answer should be 52.4 inches squared. Awesome job. Okay, 27. Notice how most of 27, it's all shaded, right? It's almost like this whole circle. It's all shaded except for this one tiny piece. And the tiny piece that's not shaded, that angle is 45 degrees. So what do you think is going to be the fraction that we're going to use to find the area of the shaded circle for 27? Okay. The other thing that we need to start thinking about in 27 is that 6. What is that 6 representing? See that the arrows are stretching all the way from one side of the circle to the other. We can start to think that that 6 is representing, do you think it's the radius or the diameter? If you said diameter, that is correct, all right? This 6 right now is the diameter of this circle. So be careful here, because here then the radius is half of the diameter, right? So our radius is 3, okay? Now, in order to find the full fraction that we need our numerator, we need our denominator. We know that the denominator is always 360 because that's the measurement of the circle. But up here, I just want to find out the area of this, all of this that's shaded. So that's 360 minus 45, so that's going to be 315. Okay. So 315 degrees divided by 360 degrees times, let's multiply this by pi. And then if you want the radius, so that's 3 squared. But you can do that in your head, you already know it's 9. Okay, so using our calculator, let's go ahead and do fraction boxes. Alpha y equals 1. Let's do 315, arrow down, 360, arrow to the right. Now we're going to do our pi. And then 3 squared is 9. Okay, if you want to do 3 squared, you can. I'm just going to put in the 9 here. And then we find out that we have a value of 24.74004,215. Rounding off to the nearest tenth, I want one number after the decimal. I'm going to look at the neighbor. If it's 5 or bigger, I change to 7. Since it's not, it's less than 5, then we keep the 7 as it is. So your final answer, rounded off to the nearest tenth, is going to be 24.7. And then here, there were no units given to us in this radius. So let's just go ahead and say it's units squared. Let me take off that little I, and then we're done with this page. All right. I hope this was very helpful for you. Remember, you can always go back and review any of the videos for this review. You can just focus on a particular problem, or if you need to look at it all over again, that's fine too. You can fast forward, you can rewind, use it as much as you need. And I wish you continued luck with your studies. This is a lot of fun stuff. I find it fun. I find it distracting from what's going on outside in the world. It gives you a little break. You get to focus on something completely different, and you're doing something good for your brain. All right. I hope to see you in video number 4. Okay, bye.